In the first example we looked at, we were adding 2 after the function was applied. Now we're going to look at what happens when we add 2 before we evaluate the function. This time we're going to be working with the function g of x is equal to x squared. So we know our outputs for that function would be, when x is negative 3, we'd have 9, 4, 1, 0, 1, 4, and 9. And our function would look like this. So take a moment to think about, how do you think this will change when we add 2 to our input as opposed to adding 2 to our output? Right, let's think here. When we take an input of negative 3, where before we just had negative 3 squared, now what's going to happen is that input of negative 3 is going to have 2 added to it before it gets evaluated. So it's going to be g of negative 3 plus 2. Well, negative 3 plus 2 is just negative 1. And g of negative 1 is down here, two units underneath, or actually higher, greater than negative 1. So that would be, or greater than negative 3. So that would be 1. So when our input here was negative 3, we got the output that we're used to getting from negative 1. Similarly, when our input is negative 2, before we evaluate that, we're going to add 2 to it. So when our input's negative 2, we get the normal output for negative 2 plus 2, which is 0. G of 0 is 0. So when we input negative 2 to this, we get 0. When we input negative 1, we'd have negative 1 plus 2. So we'd actually get the output for 1. So we'd get 1. Now that's the same as it was for negative 1, but really what's happening is we're getting this output. When we input 0, we're getting 0 plus 2, which is 2. So we're getting g of 2, which is 4. This should make sense if you think about it, because g of x plus 2 is really just going to be, we're replacing the x with x plus 2, so we'd have x plus 2 squared. So when x is 0, this is 2 squared, which is 4. When x is 1, this would be 3 squared, which is 9. When x is 2, this would be 4 squared, which is 16. I'm good at numbers, I swear. When x is 3, this would be 5 squared, which is 25. Now, it might not be obvious from our table exactly what's happened, but you may see that for every input that we had here, we actually got the output for 2 greater. So when we input 0, we actually get the input that we would usually get from 2. Let's go ahead and plot these points real quick, and maybe we can see the pattern a little better then. We've got negative 3, positive 1, negative 3, positive 1. We've got negative 2, 0, negative 2, 0. We've got negative 1, positive 1, negative 1, positive 1. We've got 0, 4, 0, 1, 2, 3, 4. We've got 1, 9, so that would be 1, 1, 2, 3, 4, 5, 6, 7, 8. 9 is going to be somewhere up there. We can kind of see our parabola, right? If for no other reason than because we can see our vertex here. How has the graph shifted? If we look at it, every single point has shifted, it looks like, 2 to the left. Shift 2, or shift left by 2 is actually probably how we should say it. Shift left by 2. Now, this is a little bit confusing because we're adding 2, so it seems maybe like we should be moving to the right, right? Because when we added to the outside, we moved up. But when we have this translation where we're adding to the input, in a certain sense, it does sort of the opposite of what we think. It shifts in the negative direction. The way that I always sort of think about that is each point is getting the value from 2 higher. So effectively, the point that's 2 higher shifts down to 0. The point that was at 0 shifts down to negative 2. We'll explore this more over the next few days, and as we do that, hopefully we'll develop a little bit of a better sense for what's happening.